flip the x and y, and we f of x is just y, right?
Yeah.
So y equals that 2/5 x minus 4. Okay, so when I flip x and y, that's going to be x is equal to 2/5 y minus 4, right?
You need to isolate the y, so add
Isolate
4 to both
y.
sides.
So plus 4 to both sides, that gives us x plus 4 equals 2/5 y. How do I take care of 2/5 y?
Multiply by
Multiply by 5
5.
halves.
Multiplied by the reciprocal, right? So then I got y equals 5/2 times that x plus 4.
F of negative x.
And you
5. 5.
can leave it that way. Well, we got to have our notation. But like if I was to distribute the 5/2 also, it'd be 5/2 x
Plus 10.
plus 10. I'll accept either one.
Wait, no, you won't, because it's y equals still.
Got it, yeah, proper notation. Another one? Verify that one too. Okay, so f of f inverse of x, that means we're going to take the inverse that we found and plug it into the original, right? So if we got 2/5 x, then we're replacing x with what we found, right? This is where having that one will help. Then we got minus 4 still, right? 2/5 times 5/2 x.
X.
That'll be just x. 2/5 times 10, that'll be 20 over 5, right?
4
4.
minus 4.
So we're good the one way, right?
Yeah.
We got to check the other way as well. Now, 5/2 x, and x is going to be replaced with the 2/5 x minus 4, right? The original function. Then we have plus 10. Okay. 5/2 times 2/5, that gives us to x, right? 5/2 times negative 4
Minus 10.
minus 10, so that'll be 20 over 2, correct?
Plus
Plus 10.
2.
And yep, they are inverses. Again, that's how you check your answer, right? Just verifying, compose them both ways.
Can we do number 8?
Number 8. Yep. Okay. For our sake, we're going to ignore the restricted domain.
That's what confuses me.
Is that what you're confused about? Remember how we had that function and relations conversation? By restricting it for x is greater than or equal to 0, that makes it so it's a function. Okay, so what we're going to find here is actually an inverse relation. So y equals that 36 x squared.
X.
Swap x and y, right?
X equals 0.
Y squared equals x over 36.
Yep. And then what do I have to do?
Square root.
Square root. And if I square root that whole thing, I can separate it, right? So then it'll be square root of x over,
6.
and then just having that proper notation. Another one?
Yeah.
Which one? What's that? Whichever. You tell me.
Number
12?
12. Yeah.
Okay, so some review on simplifying radicals, right? So like cube root of negative 16 x cubed y to the 5th is e to the 10th. So remember, just break it into its part, right? Parts. Do the cube root of negative 16, do the cube root of x cubed. Now, if I got a cube root of a negative, that means I'm just going to bring a negative out as
Yeah.
well, right? Then you can just concentrate on the 16.
Do an 8.
We're doing cube root, right? So looking for groups of.
I don't know when that happens.
So negative 2 will come out, correct? How many x's will come out?
1.
1? Because 3 divided by 3 is just 1, right? Cube root of y to the 5th?
Why?
Y and there'll be there are 2 left.
2 left inside, right? And we had a 2 left in there, correct?
Is this?
No x's, we had a y left, 2 y's left in there. Cube root of z to the 10th?
3.
And then 1 left inside, right? 10 divided by 3, that's 3 remainder 1. So 3 will come out, 1 stays in. Any others?
Do 11.
11. Okay, so if I'm taking that whole thing to the 1/4 power, right? 81 x to the 4th y to the 8th. Taking that whole thing to the 1/4 power.
Oh yeah.
When I take something to the 1/4 power, what is that saying? Fourth root. Fourth root of 81. Anyone know what that is?
3.
That is 3. 9, 9, 3, 3, 3, 3, right? Got that group of 4. Fourth root of x to the 4th.
X.
Fourth root of y to the 8th.
That's not quite the answer yet. No.
Not quite. We had an even index, right? And we have variables. What do we have to consider?
Even odd.
Even, odd. Does any x or y follow even, odd?
X.
X does. I gotta have those absolute values around x, right? Both x and y follow even, right? But the result, x was odd, y was even, right? So the x follows even, odd. Good on that? Okay. 7.5 then. Not too bad of a lesson today.
Oh, what the?
Graphing square root and cube root functions. We did domain, what was that, Thursday? Okay, we got a picture of what they look like, right? Square root functions had the 1 branch, where cube root functions had 2 branches, right? Okay. Now, the standard form, or general form for a square root. What do you notice? A, H, and K. So is the way we kind of approach these any, I mean, it's a little different, but is it much different than what we've done all year? Oh, we're going to figure out H and K, and A is going to go off to that point, right? Cube root functions, same thing, it's just cube root. Now, back when we did conics, it was x minus h, y minus k, right? So then we would have to think opposite for both. Okay, we got to reset our thinking back to what we used to. Opposite of what we see with x, what we actually see for k, right? So again, it comes back to plus k now. So we're always going to figure out hk, plot that point, and then we use the table for a, right? And from that table is where we get our other points. Now, for square roots, anytime we've done this, that's the part that's changed, right? Depending on what type of function we've done. Hey, did you start this? Okay, perfect. Thank you.
No problem.
Now, if we're doing square root, we always want to figure out good values for x, right? What are some good values to square root?
0, 1, or
Eight,
Uh,
nine,
Your perfect squares, right? We don't need to worry about 0 because 0 is just our HK point. Okay. So now, middle column, we always take the actual square root of that, those x values, right? Square root of 1, square root of 4, square root of 9. Will those two columns ever change? Unless you want to make it harder on yourself, go ahead, but I wouldn't. I mean, you could go beyond that, do 4 squared, right, 16. But if we go right or left 16, that's going to put us way off to the side, right? Now, a value. So let's just do the parent function so we can see what the parent function looks like. H and K are 0, 0, A is 1 on the parent function, right? So the A value in this case is 1. And when I multiply the middle column by 1, does that change it?
No.
No. Then we'd always ignore the middle column, right? And again, on the parent function, we said HK is 0, 0. So based off that table then, where do I go from that point?
1, 1.
Right 1, up, and yeah, it ends up being on 1, 1, right? Right 1, up 1. Right 4, up 2. Right 9, up 3. And you guys remember when we did domain on these types of functions? X square roots only had one branch, right? Because can I plug in -1 into a square root? No. So we just got that one branch, right? So on a square root, you start on your HK and you go through those other points that you found. Cube root now. Can we do negatives with cube roots? Yep. So now, what are some perfect cubes?
1, 8, and 27.
Okay. And 27 is going to be way off, so we're not going to worry about that one, right?
-1?
Here we're going to want -1 and -8 as well. Because I can do the negatives, right? Square root of -8. Or cube root of -8.
-2.
Cube root of -1.
-1.
Cube root of 1. Cube root of 8. So again, nice thing about square root, because some functions we've had to be specific with what x values we use, right? Okay, square root, cube root, those two, you should use those values every single time. Okay. Now if we do the parent function, a value is 1, right? Well, that doesn't change. So then, that's saying left 8 down 2, right? Left 1, down 1, right 1, up 1, right 8, up 2. Now we got 2 branches, right? Okay, so those are the parent functions. Now, once we start getting H and K value and A values, H and K again just shifts it left and right, up and down, right? Okay, and then A value is what's going to stretch it or reflect it, just like it's been all year. Questions on the parent functions? Okay. So let's go ahead. Let's graph a cube root. Y equals the cube root of x minus 2 plus 1. What's our HK value?
2 and 1.
1. Opposite of what we see with x, what we see for the k, right? Okay. Now, that point is called it's called the inflection point. Okay, so if I refer to the inflection point, that's your HK point. So 2, 1. And now everything we do now is going to be based off that point, right? Okay, so for the cube root function, what x values do we use for the table? Okay, and the cube roots of those were right? putting those values. Now what's the A value?
1.
1. That's not going to change at all. And again, we ignore that middle column now, right? That just helps us get to that A cubed root of x. Because A cubed root of x, that's our y now, right? So where am I going from our inflection point? Left 8, down 2. You got a question, bud?
No, it's just going a little bit fast for me.
Okay, I'll slow her down. Okay, so left 8, down 2 from that point, right? Okay, next one.
Left one down one.
Left 1, down 1. It's always from the inflection point, right?
Mhm.
Okay, next one.
Right one, up one.
Right 1, up 1. Then finally,
Right 8, 2 up.
right 8, up 2.
Up 2.
Okay, now we got the points we need, right? There's our graph. Okay, now, domain. Think back to our domain lesson. What were the two cases where we had restrictions? Negative inside of a square, even index root, right? Square root, which includes that. And variable in denominator. Do we have either of those cases? No, we got a cube root, right? And just based off the graph, what's our domain? X element of all reals, right? We don't have any restrictions with cube roots. Range? Is that ever going to stop going up and down?
No.
No. So at any point, I can plug something in and I'll get something back, right? And no matter what I plug in, I'll get something of the whole range at some point, right? You got a question?
Yeah, so is it never going to have restriction with this people?
Nope. So always going to be X element of all reals. And same thing with the range
For all people or just this one?
for all cube roots.
Provided there's not a fraction.
Okay?
Mr. H, that is of course assuming there's no fractions, right?
Well, there's fraction changes though. I'll still get something back, won't I?
You know, but if X is something you want, then
We won't do anything like that. Questions on that one? Okay. HK, our inflection point, will be what here? 3, 2. Let's go ahead, let's make that a different color so we know. I think a mistake that some people will make is they don't go off the inflection point. Once you start adding those other points, it's kind of easy to lose it in there, right?
Mhm.
Let's make that one black. Okay, cube root. What are my x values I'm going to use?
1, 8,
Just those perfect cubes, right? Cube roots of those.
-2, -1, 2, and
Now we actually have an a value, right?
1.
Which is, so we're going to take that middle column times that -2, right? So -2 times -2, which will give me 4. -2 times -1.
2.
1 times -2. And then 2 times -2, right? Don't worry about the middle column now. Now, that -8, 4, what is that saying? left 8, up 4. And we had left 1, up 2, right? Right 1, down 2. Right 8, down 4. Again, do we have a restriction at all on cube roots? No. So just make sure, domain, you got X, range, you got Y. Now, what do you notice compared to the parent function on this one? Flipped, right? Reflected. What caused that? Negative A value. Okay, so negative A value reflects it. Then we also had 2 compared to 1, right? It stretched it. Up and down. Questions at all on that one? Okay,
When were we supposed to work ahead?
when I say, I haven't said anything yet.
Oh, well, I'm already done with the notes.
Okay, then just pay attention. Need to wait a minute, bud?
Yeah, it's like we have 2 things open.
We can come back to it and finish, okay, Al? Alright. So, is this a cube root or square root?
Or,
Square.
so no negative.
So H and K in this case?
Minus 3, 5.
Negative 3, 5.
Negative 3, 5. So everything's off that point now, right? What values did I use for the square root functions?
149.
4, 9. Those perfect squares, right? Square root of 1?
1.
Square root of 4? Square root of 9. A value in this case was? Okay, so we take that middle column times that now, right? Which will give me what?
4, negative 6.
1 times negative 2 is negative 2. 2 times negative 2 is negative 4. 3 times negative 2 is at negative 6. Lower the middle column, right? Now remember, with square root functions, how many branches will I have?
1.
Just 1. So again, we got a restriction on our domain, right? So that's why we only get that 1 branch. Where am I going from the, not an inflection point anymore, just our HK?
Right 1,
Right 1,
down 2.
down 2. Then,
Right 4, down 4.
Right
right 4,
4, down
down 4, and
Right 9, down 6. I know we have a restriction on domain, but I think we also have a restriction on range.
we do. Okay. Everything is to the right of that, isn't it?
No.
Okay, so that's my restriction on my domain.
Well, everything is to the right of that except for that itself.
Yep. Yep.
Hence
What
why
is
we-
that? What is that x? We're always dealing with the x, right? With domain.
Greater than or equal to -3.
Negative 3 was that x coordinate there. And if we go to the right of it, greater than or equal.
You're gonna also make us write XER such as that thing.
Oh, do you want
Oh,
to?
come on, you make us write that sometimes, but not other times.
Yeah. It's
There
yeah.
are other reasons for that.
Just when you get to higher levels, they'll expect that. When I grade it, I just look at you have x is greater than or equal to negative 3. Just trying to get you guys in the habit of doing that, though.
Would
Yep.
you like us to write one thing or no?
The XER.
Yeah. Or,
Like I said, it's a good habit to get into. I'm not gonna dock you if you don't, though. Okay, range. We're below that now, right? What's that y coordinate?
Always less than or equal to.
Alright. Everyone understands why it's less than or equal to? Caitlin, did you have a question?
Is it always gonna be rotation immediately?
Yep. For the square root functions, yep. 'Cause I mean, that's kind of the critical point where everything happens, right?
Yeah.
Where it's above or below, or left or right. So yeah. So that H will always be part of your domain, the K will always be part of your range. Go ahead, give that next one a try.
Mr. What time does the school day end?
It depends, are you 1 through 7 or 2 through 8?
So, 2, 3, 8, 3:35. 3:35? Yeah. Oh, that is 3 hours. Thirty and a half hours till the end of tomorrow. Service watch it up.
I should have it on there by this afternoon. Okay, square root function, right? HK. -4, -1. Okay, x values we use.
Well, 149.
149, those perfect squares, right? Because I can square root those easy. 1, 2, 3. What's our a value?
246.
Times 2. So 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. Where am I going from my starting point?
Right 1 up to
Right 1 up to
right 4 up 4.
right 4 up 4.
Right 9 up 6.
Again, that's what's that point right there is going to help us with domain and range, right? Which is just our HK. So, x element of real, y element of all real. That's that. X is something to that -4, and y is something to that -1, right? I went to the right, correct? Which means greater than or equal to. Range, I went up from that point, meaning greater than or equal to. Questions with graphing? I mean, for the most part, graphing has been very similar throughout the whole year, right? So hopefully we got this idea down with A, H, and K. Now, homework, 7.5 books there, first part. We're just matching up those functions with the graphs. Okay, so for the most part, identifying your H and K. Now, next part's square roots. Second part, third part, there's cube roots. Go ahead, you can ignore the word problem. Real quick though. For this function is this, y is equal to the square root of x minus 2, or y is equal to the square root of x minus 2?
The first
What?
one.
It's the first one, right? Only x is being taken to that 1/2 power. If it was this, it would look like this. Right? That the whole thing of x minus 2 is taken to the 1/2 power. Keep in mind, only the x is that 1/2 power, right? So only the x is under that square root.